Good morning. I think this is the first time I've ever given an opening talk at a meeting, and it's certainly a different kind of pressure from giving a 4 o'clock on Friday talk at AGU, and trust me, I've done those as well. I'd like to thank Pinchan for asking me to give an overview talk this morning on the sort of the hydrologic cycle, and this is very much an overview. I took him very seriously, and so it'll be a fairly general talk, but it'll talk a little bit about what we know and think we know. You know, certainly as we look at the next century, I doubt anyone in this room would argue with the fact that we can expect temperatures to rise, ice to melt, and sea level to rise. But I think probably the biggest factor that affects humanity is really the availability of water. I think we can adapt to temperature change, we can move inland as sea level rises, but the availability and distribution of fresh water is really a very critical factor, and it's something I think that paleoscientists can address, at least in terms of the past. Because quite simply, without water, you die. If we look at the sort of this is a very funny perspective from up here. If you look at the distribution of sort of arid and semi-arid regions in the world today, there's sort of a natural tendency to think about sort of, you know, people who live in regions like that and the implications for water availability. But certainly in regions that, you know, get a lot of rain, where that rain is seasonal, there are certainly concerns about the availability of water as well, because if the rains don't come or they're delayed, significant impacts, of course, can occur. As paleo science has gotten better, as records have become higher resolution, age models have improved, there's been a tendency to merge that work with the work of historians and archaeologists, and from that I think we've developed a pretty good idea that in fact drought has had important effects on human history, whether it's the abandonment of the very first English settlement along the east coast on Roanoke Island in the late 1500s, or the abandonment of the cliff dwellings in the Four Corner regions by the Anasazi, the ancient Pueblo people, in the 13th century, or the fall of the Akkad Empire in the real cradle of civilization, the first sort of real agricultural-based society 4,000 years ago, or the Maya, the collapse of the classic Maya civilization at the turn of the millennium, or the Tiwanaku and the abandonment of their city-states in the 13th century. And even as I learned in the pages of National Geographic just a week ago, the perhaps related to the fall of the Khmer Empire in the early 15th century. And there's even some suggestion that, you know, some of the dynastic turnover in China perhaps can be related to drought as well. And certainly as we look to the hydrologic future, you know, forecasting ahead, that's mostly done with models. This is one of the ITCZ projections that I think people, I'm sure, have seen. And again, this is really just sort of a projection of precipitation. But the thing you immediately gather from looking at a figure like this is that, you know, changes are in store. Some regions drier, some regions wetter, but, you know, clearly changes that will have serious implications for what the future brings for us as humanity and the world as a whole. Of course, we're paleoscientists. We're trained to look backwards instead of forwards, and that, you know, goes hand in hand with sort of the retrospective theme of this meeting. And so our question really is, what can we learn about natural changes in the hydrology of our planet from looking backwards? I have to say, I used to think that Henry David Thoreau was a wise man indeed, but I'm sure he's been misquoted here. I suspect that this is really what he intended to say. I, for one, know that after a few beers, I'm much wiser myself. There's certainly ample evidence from things like tree rings and even long historical records that, you know, prior to the pre-instrumental time period, that drought, you know, occurs, you know, and has been a periodic phenomenon. I mean, the idea of sort of decadal scale droughts is something that we're all, I think, familiar with. As we look further back in time, of course, we see evidence of megadroughts, essentially long periods of extended dry conditions that have no recent historical counterparts, such as seen in this sort of classic record from Moon Lake, North Dakota, prior to about 1200 AD. Not just short droughts that lasted a few years to decades, but droughts that lasted centuries in a very different sort of regime during this period of time, relative to the period of time we're, of course, more accustomed to. In the mid-1990s, Dave Hodel and colleagues taking cores in the lakes of the Yucatan Peninsula, came up with evidence that there had been sort of an extended dry period about the time of the collapse of the Maya civilization. This led to the idea of sort of a century-scale megadrought that may have affected these people at that particular time. More recent work has suggested that within that sort of extended dry period, there may have been sort of periods of shorter, sort of multi-year decadal scale drought. And in fact, these periods here seem to coincide with some of the timing of the abandonment of cities in the Yucatan Peninsula. As we look to Africa, lots of examples can be found, lots of things in the literature that deal with, essentially the history of drought in the true sort of cradle of humanity. Whether it's Peter Domenical's work off the west coast here, looking at Aeolian deposition and essentially documenting the long sort of African humid period persisting for thousands of years with an abrupt onset and abrupt end. Or if we look over here to the east at Dirk Verschuren's work on Lake Naivasha in Kenya, again, evidence from lake level records that there were periods of time, a century or so in length where lake levels were considerably lower, and again, having impact on some of the turnover of some of the changes in sort of East African society during that time period. And again, very recent work, just as an example, Tim Shanahan and colleagues' work from Lake Basumtwi, the little impact crater here in Ghana, drilled by ICDP, and again, evidence of sort of decadal scale droughts. So just in these three examples, we have evidence of sort of droughts on the time scale of decades, the time scale of centuries, and the time scales of thousands of years. Now, of course, when we think about abrupt change, that really is the title of this session, the global hydrological cycle and abrupt change. Of course, we tend to think of Greenland and the ice core records, which have become essentially sort of the de facto type section for climate over this period of time. Everybody compares their record to Greenland. But of course, Greenland is really a record of temperature at that particular location. And the question is, of course, how does the rest of the world respond? My introduction to sort of abrupt climate work and sort of interest in the hydrological cycle sort of developed in the early 1990s when John Overpeck and I started poking holes in Cariaco Basin here in the Southern Caribbean. And Cariaco has many of the sort of the ideal characteristics for what you'd like records to have. It's an anoxic basin. It's been anoxic through much of its history, so there's very minimal bioturbation mixing of the record. The sedimentation rates are very high because of the nearshore location. And it's located in a region that's extremely sensitive to the position of the intertropical convergence zone, especially on a seasonal basis, because it's the seasonal movement of the ITCZ and the effect on the rainy season, the dry season, the upwelling season, the non-productive season, that results, because of the anoxic conditions, in these beautifully laminated sediments that you see here. So this is a basin that is very sensitive to the ITCZ. A number of papers have come out of work that we've done using, in part, just a simple titanium input measured by scanning X-ray fluorescence techniques as sort of a proxy for the riverine input into this basin from the local rivers. And again, you can choose to look at titanium or aluminum or silicon, and they all pretty much, iron pretty much give the same story. And these records are now starting to be backed up by a variety of others. Catalina Gonzalez's pollen work, other regional records, coupled 018 magnesium calcium records, recent PhD work by Martha McConnell, all pretty much give the same picture. Where we have, for example, in the latter part of the record, sort of a dry, younger dryas interpreted, sort of a wetter period here, and sort of a steady decline in riverine input. If we're looking back during stage 3 at the interstadials, again, high titanium and presumably wet conditions associated with the warm interstadials and dry conditions associated with the colder periods in between. And the simplest way to explain this, I think, at least, particularly given Carriacca's location, is that what we're looking at here is simply changes in the position of the ITCZ in a pattern that more or less mimics the annual cycle, where when essentially the high latitudes are cold, essentially we have the ITCZ sitting further to the south, either further to the south on average, maybe it's a seasonal thing, but that essentially draws the rains away from Carriacca. And conversely, when Greenland is warm, the high latitudes are warm, essentially the ITCZ sits a little further to the north. And as one moves to the south, in fact, what one finds is that, the hydrologic patterns as you go south are basically opposite. Here's the Arts et al., Helga Arts's work from the late 1990s, looking at the input, again, using titanium and iron as a riverine input proxy from a core off northeast Brazil here. And showing that, basically during the time of the Heinrich episodes in the North Atlantic, we have increased input of, essentially material into this region in a pattern, basically opposite to what's going on up here. Here's the Wang et al. Study from 2004. The data on here come from speleothems and are really represented by the vertical yellow lines here, which represent, the times of speleothem growth. And of course, the speleothems grow when the conditions are wet. But again, though, both these records indicate, essentially a hydrologic pattern that is opposite to what we see to the north. Other records as we move to the west, if you look at sort of what's going on in Lake Titicaca and Salar de Uyuni, I can never pronounce that, work by Sherry Fritz and Paul Baker and others who've been involved in that region there. Or if you look at, sort of comparisons between Carriacca and the results from the Quelccaya ice core, Lonnie Thompson's work here, again, you see sort of the interpretation would be sort of an opposing pattern of, sort of dry to the north, wet to the south, wet to the north, dry to the south, on, sort of very different timescales here. Now, of course, explaining what's going on in these records here, as is true for much of the interior, is a little bit complicated or more complicated in terms of a simple sort of ITCZ argument, because the ITCZ is really a feature that is well developed over the oceans and becomes much more diffuse over the continents. And in fact, most people would say that much of the rainfall in the continental interior here is the result of the South American monsoon. And that is certainly true, and the relationship between the monsoon and the ITCZ, I think, is probably complicated, but I suspect there is a relationship that does exist, because you can't deny the fact that these patterns, these hydrologic patterns, are in fact out of phase with respect to each other. And of course, those patterns are consistent with what modeling studies have suggested. A number of studies, Ling and Wood, Zhang and Delworth, others, hosing experiments, basically where you flood the North Atlantic with fresh water, you essentially, collapse or slow down the meridional overturning circulation. This results in an altered sort of latitudinal temperature gradient. And what the models suggest, this is a precipitation field, is that in fact the locus of precipitation shifts to the south, and this has been interpreted as a southward shift of the ITCZ. So again, the paleo data are seen to be very consistent with this interpretation. Now, if you notice that, essentially this is a very robust and sort of a strong signal in the Atlantic, it becomes less clear as you go further afield as to, whether the sort of flooding experiments and the meridional overturning circulation provides an argument that can be extended to regions further afield. And so as we look at Asia, as we look east or west, I guess, depending on which way you're facing, many of the best records from this region are coming from speleothems. And again, many of these are classic records that we're familiar with. I'm sure almost everyone here, the Hulu Cave record by Wang et al., published in 2001, which showed the, sort of this wonderful record where you can basically pick out, essentially sort of every millennial event that you see recorded in Greenland, all the DO events in particular. Again, these are interpreted in terms of the hydrology, wet, dry, again, suggesting wet conditions when, essentially it's warm in Greenland. And then superimposed on that, sort of evidence of, sort of a precessional effect related presumably to local insulation. The Donga Cave record by Yuan, at all, again, further to the south, but, overlapping nicely with Hulu in the portions where it does overlap, and also providing important information down here in the sort of the time interval of marine isotope stage 5, again illustrating sort of a strong precessional component to the sort of the interpreted hydrological changes. This is the record from Yancheva et al. From Lake Huguan Mar. This is a little different record. The record's in the middle here. This is titanium magnetic susceptibility properties. The 3 records here are from this particular lake. These are interpreted in terms of essentially changes in the winter monsoon and essentially the source of the material that is creating the magnetic and the titanium signal. So this is not a summer monsoon signal like the Hulu and Donga cave records up here, but clearly showing a similar pattern, indicating that sort of the monsoons as a larger feature are involved over this time scale. Other records, and again, there are others we could point to, the Timta Cave record by Sinha et al., covering some of the interval of deglaciation, the Mumi Cave record here from off Oman by Steve Burns et al. With the corrected chronology. Again, sort of indicating this very clear pattern of, at least interpreted, sort of wet during the warm times in the high latitude North Atlantic. Here we have the Wong et al. Record that was published in 2006. This is the wonderful comparison between Hulu Cave here and Butavera Cave here in South America. This particular rendition sort of covers the time interval, as you can see, from 10 to 40,000 years. Hulu Cave in red, Butavera in blue, but plotted inverse to each other. But again, you can see the remarkable correlation between these 2 records, where you can see essentially, sort of DO-like cycles, and the sort of the longer term change here. But again, antiphase to each other. When one is wet, the other is interpreted as dry. And here we see the extension of that published a year later. So this is now Butavera Cave for the last 90,000 years. This is Hulu Cave, Donga, sort of patched together, plus one other cave record that was unpublished at the time, whose name I can't remember. But again, these are plotted inverse to each other, and so you see this sort of wonderful antiphase relationship between the 2 records, not only on the millennial time scale, but the time scale of precession as well. So I think, this pattern of sort of the alternating wet, dry, sort of the antiphase between the 2 hemispheres seems to be fairly well established, although admittedly southern hemisphere records are still lacking. Just to look at a couple other recent records here. Here's some results from Lake Petanitza, essentially the drilling project in the Guatemalan lake, again undertaken by ICDP, where, just by looking at the lithology of the cores, you can see, there's clear sort of visual evidence of alternating wet and dry episodes as you go from essentially, clays to what are essentially gypsum sands. Those lithological changes show up very clearly in the physical property records, such as magnetic susceptibility and density, with the high susceptibility values associated with the essentially the clays, the low susceptibility associated with the salts. And here in this figure, compiled by Dave Hodel, is a comparison of the Petanitza record to essentially the GISP ice core record. And again, what you see is, sort of a pattern of interpreted very dry conditions during Heinrich events, but in between, essentially DO-like events that appear to be wet, again, in a pattern very reminiscent of what Cariaco shows. And given its location, that's probably certainly what we would expect. Here's another figure from Hodel's work, again, just showing, again, making the point of sort of the interhemispheric contrast. Here is the Petanitza record. Here is Helga Artz's record from essentially off northeast Brazil. So the gray bars are the Heinrich episodes where it's dry here and clearly wet here, based on the input of riverine material. Just a couple other records to look at quickly here. More recent, again, fairly recent records. This is the Lake Malawi record of Eric Brown. et al. Published in 2007. And again, this is not really a record that relates to lake level or wet-dry per se. What the primary data here is this ratio of zirconium to titanium, again determined by XRF scanning. And essentially the variations here in this ratio are interpreted to reflect the variability in sort of volcanic dust that's coming in with the sort of the northern winds. And so this is interpreted as basically being sort of wind direction and prevailing input of aeolian material. But essentially the wind direction is affected by where you are with respect to the ITCZ, because if you're to the south of the ITCZ, the winds are expected to come from the north and vice versa. And again, what's interesting about this record is if you look at it, if you just sort of looked at this portion here, there would be sort of a natural tendency, I think, to look at these and sort of this pattern of peaks and try to sort of visually relate them to the interstadial events here, the DO events here. But as you can see, if you look carefully as you sort of extend the yellow bars up, in fact, these are interpreted with the chronology that's available to essentially coincide in time with the cold stadial events. In fact, I was just looking at the abstracts for this meeting last night. I was much wiser then because I'd had a few beers, and noticed that the Eric has a poster here, I gather, that talks about sort of an improved chronology and how in fact these events here do seem to coincide with the cold stadials and not the interstadials. And I think if anything, this figure makes a really good point about how chronology and age models are so important to what we do. Because again, visually, one would tend to look at this and sort of the natural thing would be to sort of match it just visually. But again, very different interpretation if the chronology here holds. But again, consistent with, essentially the story from these other records. Finally, this is paper from Molitza et al. Published a year or so ago in paleoceanography, looking at, again, input of dust at a core off of West Africa here. Shown over on the right is, essentially a plot of rainfall. Precipitation is a function of latitude. And the red symbols here, which I've just used to enlarge the symbols that were part of the original figure, illustrate variations in the iron-potassium ratio of the dust collected offshore here. And the interpretation of this is that, under the high rainfall regime and more chemical weathering, essentially this ratio changes because of the more intensive chemical weathering, preferentially releasing iron. And when you take that figure and you sort of turn it around like this and line up the latitudes, what you can see is that, again, at the location of that core, you would expect fairly low ratios. But if you just sort of imagine this belt of rain, sort of moving back and forth in a north-south direction, how that ratio, in fact, would be expected to change. And in fact, that's what you see. Here is this is Greenland at the top. This is the benthic Delo 18 record from the Molitza core. And this is the essentially iron-potassium ratio. And aluminum silica interpreted in a similar way where, essentially the lower values of the ratio, which here line up with the Heinrich events, are interpreted essentially as dry, more arid, and changes in the composition of the dust. What interested me about this record is I thought, well, what does it look like in Cariaco? Because we've done a lot of XRF work, and we can look at iron and potassium and other elements in a very similar way. These samples here were all done by discrete analyses, not by XRF. But if you take the XRF record from Cariaco, from one of our Marion Dufresne cores here, and again, this is a highly smoothed record, and you couldn't really compare this ratio to the ratio here because this is based on a ratio where the data is in percent form. This is a ratio based on counts. But what you can see is, I think, sort of a remarkable similarity. In fact, perhaps because of the higher resolution of the Cariaco site, the high sedimentation rates, that even highly smooth, you can see a record, I think, of almost every interstadial here in terms of this particular record. So again, sort of one more line of evidence reinforcing the basic titanium story. Now, what's interesting is that this record only covers 60,000 years. In Cariaco, we can extend that back. and we see something that looks like this. So here's the iron, the iron-potassium ratio in Cariaco. We had previously looked just up to this point here, but when you extend it back, you see actually something that I found to be quite surprising. And again, literally, I just did this a few days ago. Again, you can see a pattern of variability here that sort of mimics the structure of Greenland here in sort of a consistent way of what, again, assuming the interpretation here is similar of sort of a wet, dry, or humid, arid. But clearly sort of a big offset that begins, right about 60,000 years ago, just as you're starting to get into the essentially marine isotope stage 3. And what that offset means, I'm not really sure at this point. It's real. I mean, there's actually an offset in the ratio when you ratio other elements as well that occurs about that time. But one thing I found interesting is if you look at the long record from Lake Malawi in Africa, this is work published by Chris Schultz et al. A few years ago. What you see is that, again, prior to 60 or 70,000 years ago in East Africa, essentially the big lakes like Malawi were very dry. In fact, by estimate, perhaps 95% of the lake volume essentially disappeared during periods like this. And essentially, sort of a transition in the lithology and the interpreted lake level records at a very similar time. And again, I'm not quite sure what this means, but again, it indicates, I think, that there's the potential for sort of abrupt changes in hydrology that may be related to essentially processes that are not simply as simple as sort of ITCZ position. Almost done here. This is just the sort of the annual cycle of precipitation, and if you sort of step through this month by month and just sort of follow it visually, it helps to look at this a couple of times. What you can see is basically the seasonal movement of the ITCZ and rainfall sort of going north and south. But you can also see, and again, maybe I'll just sort of, if I can back that up and run it through one more time. Assuming it runs. Yeah, I mean, if you look at sort of the regions where, again, you have, precipitation related to, sort of, classic monsoon interpretations, you really do get the feeling that, essentially the ITCZ and the monsoon, much of this is sort of linked in a similar way. Is everything driven from the North Atlantic? Of course, that's an interesting question. Is the North Atlantic the place where the single stone is cast and then, essentially the effects ripple through the system? Essentially, does the meridional overturning circulation indeed influence things here and then, sort of changes propagate throughout the tropics? There are all sorts of interesting questions about, what's the potential role in the tropics. One I like in particular is sort of this idea of, sort of changes in the meridional moisture transport. This is work from Guillaume Leduc. And again, as the ITCZ moves north and south, precipitation escapes from the Atlantic to the Pacific. Potentially, that's what Leduc's record here, which is a salinity record from the eastern equatorial Pacific, seems to show. And again, as that moisture escapes and you build up salt, it's that salt that potentially preconditions the sinking in the North Atlantic and may act as a source of, sort of additional feedbacks. So there are lots of open questions that we, hopefully will answer at some point, perhaps even some at this meeting. Is essentially the hydrology of the tropics simply reflecting shifts in the ITCZ? What are the relationships between the ITCZ and the monsoon? We tend to think of these as sort of separate processes, but in fact, I suspect they must be interlinked in a complex way. What's the role of, moisture transport, both zonally and from low to high latitudes, and how does that feed back into the system? How does precession influence insolation? Or how does precession-dominated insolation in the tropics, essentially affect hydrology? And then finally, basically, what are the underlying mechanisms behind abrupt climate change, and in particular when it comes to these various triggers? And so there are lots of questions, and like Homer Simpson, hopefully we'll find the answers either now or eventually. Thank you.
We have 3 minutes for questions, please.
Oh, 3 minutes.
We start early. Yeah.
Larry, how consistent is that ITCZ projection that you showed? Is that there was some stippling that hinted at model agreement, but is that a universal result?
Well, I'm not really the person to sort of ask about. I'm sure there are people here that can answer that better than I. I mean, that stippling pattern, as I read the caption, because that's sort of what I did, basically suggests that those stippled areas are where, some fraction, I think it was 75% of the various models used by IPCC, come up with similar results. So, how robust that is in a modeling sense, I'm not the person to answer that. But clearly, if those models are correct, I mean, you are looking at substantial redistribution of moisture, and I think intuitively we would just expect that. Whether those patterns are correct in an absolute sense, I'm not sure.